Everybody, it's Tyler here. I'm here at the FTC Green Bay Hackers event qualifier, checking in with 14631 Laser Tag. This team already went under their belt earlier this year. Congratulations on the great success with that. But this is an incredible machine. I mean, aesthetically very pleasing, obviously, but there's a lot of great functionality that goes into this robot. Some great things with autonomous mode, some new stuff they're looking at doing with the pinpoint as well too, so pay attention to that. But we're going to be going through a lot of the different mechanical features on this robot also. Great elevator, great deposit and intake as well too, some great hooks as well. So let's learn more about them coming up here on Behind the Bots. This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. Studica Robotics offers durable, polished, and anodized aluminum channels with several new colors coming soon to customize your robot at studica.com/robots. No rough edges and a versatile hole pattern allows for positioning at multiple angles. Feel the Studica Robotics difference, and if you're in the USA, request a structure sample for your team at studica.com/robots. True competitors know that every second counts. That's why Kettering University challenges you to dive in right away as a first-year student. Participating in robotics programs helps Kettering students secure a valuable co-op. Whatever your interest, Kettering gives you more space to work faster and win faster. Learn more at kettering.edu/vex. Liam, let's start out talking about this intake that you have in the basket as well too. Walk me through how it's working out for your team.
It's working out great, actually. So the way we actually pick up our samples is using a wedge and a rubber wheel that we rotate using a servo attached to our arm. And that way we're able to successfully push and wedge the sample into our intake and then deposit it into our lovely basket area, which we call the lobster hopper, of course, to stay in theme. And then we can outtake the sample and spin the wheel backwards to go into our lovely lobster hopper, which we can move up and deposit our samples nicely.
What made you want to go with this design overall? Why did this one work out so well for Laser Tech?
Well, originally we decided that it would probably be fastest to try and go in with an intake, just simply because we have had a lot of experience using intakes in the past, and we can pretty easily just ram into the samples and pick them up and move them out. It's very nice.
Well, Kyle, that leads us into the next part with the specimen scoring as well too. So talk to me more about how you're scoring those specimen on the hangers and what mechanisms are being used for that.
So our main method of scoring is the specimen hanger right here. This is 2 pieces of rubber. Our human player is able to place our specimens on the wall, and we ram into the specimen, and it is able to pick up just like this. This is connected to our elevator, so it's able to raise up to the high rung and place down and detach from the specimen as it goes down. This is our elevator. They are Mizumi slides. In previous years, we have used Go Wilda Viper slides, but we have used these because they are lighter and more efficient this year.
When you were experimenting with different ways of scoring that as well too, what other maybe ideas or designs did you come up with before you landed on this one?
We went through a lot of iterations, but we ended up with rubber because it was the most efficient to pick up and deposit.
So Liam, on here, I noticed you got the hooks on the front of your robot. Going to level 2 up on that, I'd love to hear just more about how that process works. And do you have any future plans to maybe climb a little bit higher as well too?
Yeah, so I don't know if you can see it, but in the middle we have a motor with a nice little spool here. And when we activate the motor, it will release the spool, and using passive assistance here, the hooks will lift up to the right height that we want them to, and then we can run into the wall and then lift the hooks up again using that same spool. And it only uses 1 motor, which we're pretty proud of.
What's your time to climb on something like that?
Yeah, 3 to 4 seconds.
And are you pretty happy with the level 2 climb, or do you have any aspirations for anything higher?
Yeah, I'd say we do. We're still working on the planning on that because we just nailed out these hooks in the last week, which we're pretty proud of. We spent a lot of time on them. But yeah, we definitely have some goals, which we're going to make sure to get out before our next competition.
Absolutely. Naomi, let's get into the autonomous modes, what your team is looking at doing for that, and we'll hop more into code. A lot of great stuff to break down with your team.
Yeah, so for our auto, we have a 1+3 on the specimen side, which we clip the preloaded one and then clip the other 3 as well, and then we park. But we also have an auto for the sample side, which is either you dump a sample into the basket and then you sweep the 3 into the net zone and then park, or you can hang a specimen, sweep the 3 into the net zone, and then park. And this is a really proud accomplishment from us because we're 9th in the world for autonomous.
Yeah, and when you're looking from doing your iterations in there, how did you go about doing some of your testing?
Yeah, there's a lot of tuning going on with the way we move based on auto, and a lot of different strategies on how we can get those 3 into the observation zone so the human player can clip them and we can hang them more quickly.
Jake, I really want to talk about, we spoke earlier doing something really cool in terms of Roadrunner and using Pinpoint as well too, how that's all coming together. So talk to me more about it and what you learned from it too.
Yes, so on our robot on the bottom, we've got 2 dead wheels, one going perpendicular, one vertically. And in the middle, we have a pinpoint. Now, this is a project we've been really working on this year with our autonomous. Currently, we are just running Mecanum Drive with Roadrunner, but we have plans to use the pinpoint by our next competition. We actually have figured out how to use pinpoint and tune it with Roadrunner, which is a thing no other team has done, or at least has posted about it or asked about it. So we have plans to make documents about having teams do that, and eventually helping other teams as like a method of outreach to get pinpoint, as long as it's a better solution than the current Mecanum Drive with Roadrunner and the 3 dead wheels with Roadrunner.
Well, Laser Tech, congrats on a great season so far. Looking great here as well too. So we can't wait to see your continued success. Thanks for telling us more about this. There's a lot of great things teams can learn from it. We can't wait to see how you do. Thanks a lot.
Thank you.
True competitors know that every second counts. That's why Kettering University challenges you to dive in right away as a first-year student. Participating in robotics programs helps Kettering students secure a valuable co-op. Whatever your interests, Kettering gives you more space to work faster and win faster. Learn more at kettering.edu/vex. Studica Robotics offers durable, polished, and anodized aluminum channels with several new colors coming soon to customize your robot at studica.com/robots. No rough edges and a versatile hole pattern allows for positioning at multiple angles. Feel the Studica Robotics difference, and if you're in the USA, request a structure sample for your team at studica.com/robots.